there's a conjecture waiting to be had here. What was the conjecture? What did you notice here? All of the subdiagonal elements from the shear matrices used to cancel out the strictly lower triangular portions associated with this pivot, when we multiplied all those shear matrices for that particular column, what ended up happening with all of those individual entries? It's almost like a super shear matrix, right? It's like a shear matrix on steroids, or like Captain Planet, right? Here's the heart ring and the fire ring and the earth ring. And then when their powers combine, you get Captain Planet. You get everything in that particular elimination underward, right? Okay, so now we have this. So we have this concept that we could actually write this thing as -1, -1, 0, 1, 0, 0, 0, 1. The original matrix that we had was 1, 1, 1, 3.0, 3.3, 3.6, 9.00, 10.89, 12.96. The upper triangular matrix that we eventually ended up with was 1, 3, 1.89, 0, 0, and I think this was like that, right? Is that right? I think there was a 0.8 right there. That was the calculation that we did. Try it. Look at, make sure that I'm not smoking anything, right? It's been a while since I saw you last night. The other interpretation of that sentence is also true. Okay, so 1, 0, 0, 0, 1, 0, 0, negative 2, 0. 0, negative 2, 1. I'm sorry about that. So here we're going to call this thing A. We'll call this thing U. And then I'm going to make a really interesting claim here. This thing we're going to call L1. And this one we're going to call L2. So L1 is the Gauss transform. This is the Gauss transform. Anybody remember we defined Gauss transform way earlier in the course?